makes you brain active.
And you got several kinds of puzzles this morning. Can you think of any other kinds of puzzles that you didn't see? Like
Crosswords.
crossword puzzles? What else?
Sudokus.
Number puzzles,
Brain teasers.
brain teasers, object puzzles, wooden puzzles, right?
Yeah.
Have all kinds of puzzles. See, what's the biggest puzzle that you've done? The 5 jigsaw puzzles. 500 pieces? 700? All right. Have you ever done a puzzle with others, not just by yourself?
Yeah.
What we're going to do now is jigsaw puzzles. All right, I have this box with me. And you know what this box, everyone knows what boxes like these look like and what information there is on these. Before even opening this box, what can you tell about the puzzle?
So look like a cover.
Okay. It's going to be a projection of the picture on the cover. Alright. What else can you tell?
500 pieces. That's 500 pieces.
Is there anything else that you can infer? You know it's going to be 46 and 34. Let's say 45 and 36. Alright? Imagine it's 45 by 36. What else can you either infer or calculate?
Size of all these?
How?
Divided number of pieces. The area of
Okay, so you can infer, calculate the number of the rough size of the piece, average size of the piece. What else? How about of the sides? Can you, for instance, infer how many pieces there will be on each edge? This is a little bit of mathematical thinking that you have to do here. You have 45 by 36 centimeters. So what's the ratio? And you know that you have 500 pieces. Can you tell how many pieces there will be on each side?
5x plus 4x.
Yeah, exactly.
5x by 4x is 5x?
5x into 4x.
5x into 4x, yes. Okay, so what is x?
5.
5, alright. So x is 5. So how many pieces are you going to have on each side?
500 plus
20 and 25. Alright. You're going to get the puzzles now. Question. Do you want the pictures or do you not want the pictures?
Actually, it is a challenge to do it.
Anyone wants to take the challenge of
We want
don't want? Shall we all start with no picture?
Okay, let us.
If any time you feel you want the picture,
Then we can get. Okay,
alright, fine.
I just have a
Great.
general
Picture or no picture?
Picture. Actually, then we have one member left if you want everything to be equal.
Do one thing. Actually, no. Observe all the pieces first. Then we can say you want to divide start out with
Yeah.
Can I have your attention for just a minute? I'm hearing from all sides, can we find borders, etc. Without looking at the borders, how many border pieces are you going to have? It's the same in all puzzles. How many border pieces are you going to have? Are you sure?
86.
How many say 86? How many say 88? 86. 86. Alright. Now, you could either calculate it, right? Mathematical, what they did. Or you could do it empirically. You could take out each edge piece and count it. Right? Now, either of these, what were we doing right now? This is the kind of thing, if you were doing an experiment, a science experiment, there's a certain kind of preparation you need to do for it. Decide what you're going to do, what strategies you're going to use, and so on. So this was the sort of preparation for this talk. Now, it's perfectly okay to look at a puzzle as something that's fun, a game. However, I would also like you to do something alongside that, which is to constantly, without any strain, but constantly be aware of what you're doing, what strategies you're using to put pieces together. Because notice, this is, you have a bunch of fragments that you're putting together to form a whole, right? What are the strategies you're using? What are the clues you are looking for? Listen. What clues are you looking for to put these together? How much are you going to introspect about the strategies, etc.? What strategies the rest of the group is using such that you can learn from it? And it's not enough to think about this. I would also like you to keep a piece of paper and a pen there so that you can write it down, because you're going to have to report it to us. Okay? As a group, you are going to have to report to us what you are doing. What strategies you are using. At various points.
There are so many doubts. There are too many.
What about these? Jungle but edges. Guys, leave that edges idea. Leave that edges idea.
She's cutting the green portion, I'm cutting the orange You take the white portion only, I can take the blue portion.
Okay. How many of you have written anything at all so far? You have.
But we will have something in our mind.
In your mind disappears. So make sure you write it. So all right. Tell me, what is science?
Systematic study.
Not a school subject?
This is a nice thing which has been made bad by
It could be information about
Actually,
things.
they will learn. We say that you need to change the way you teach us.
Okay, so it could be, is this a possible definition of science? Information about things around us, living and non-living?
Yes.
Okay. Something we do in a lab?
No.
Not exactly, that's experimentation.
Yeah.
It's a part of
It's a part of science.
Alright.
It's part of learning science.
Learning science, doing science. Okay. How about that?
Yeah, that's
This one is
perfect.
the
It's pretty
Perfect!
Yeah.
Wow! I didn't know science had a perfect definition.
But it's close to perfect.
Alright, great. So, what does this have to do with science? What you're doing right now?
It's a quest to finish the puzzle.
Is it
Then
only a
there's the
quest?
skills which we will have when we are looking at something.
To be
We
solved.
need to solve it. So we have to collect pieces from all parts of the knowledge we've got. So something like that.
So it's piecing together facts to get the big picture.
Yeah.
Okay. Any comments from that section?
To have patience for doing something. We lose patience even while doing science, so that's it.
Okay. Alright.
Yeah.
What is scientific inquiry?
Questioning everything.
Questioning everything. Okay. Right? You don't just question. You make careful, systematic observations, which is something you have to do now. Right? What else?
You conclude something logically.
Okay. You arrive at generalizations. based on your observations. You create concepts, definitions, laws. Try to think if that's possible, if it's possible to create any kind of generalizations and principles in doing puzzles. What else do we do? You categorize, you infer, you reason. Notice these are all things that you're going to have to do, except perhaps creating concepts and not perhaps definitions, but concepts and laws. You might find you're doing it as part of doing the puzzle. Okay.
Actually, that's what I have to
Save something for the next 2 days, please.
We've been talking about your feedback, not feedback, but reflections on puzzle. How it has come together, what your problems have been. Are you sitting in your groups or are you all?
The starting was very tough because we had no picture and I didn't know which piece goes where. And for example, the sky, all the pieces are white, so it's really difficult to connect them. And we learned teamwork in this. I constantly feared that I lost a piece, and when the last piece fitted, I was very happy.
Yeah, we learned how to observe everything from different perspectives. And one of the most frustrating things were, we are doing something and then someone calls like, okay, time up, let's come and have it with your and your.
Maybe we have solved many puzzles before, but then here you have to mix up with the whole team and do it as a group effort. So it might take more time, you know. And these animals, they were very confusing, especially the giraffe and the zebra.
Okay.
And the thrilling experience is like when you just find one single piece, I don't know, you just get this boundless joy and you feel very happy. And one very big frustrating thing is like you have the piece right in front of you and you're searching the whole lot for it. And you keep thinking that you've lost a piece.
Now, if you notice, there was no competition here, and there was no requirement that you have to finish the puzzle. And there were some puzzles that were more difficult than others, but that would also depend on what perspective you come from, where you start, what kinds of strategies you use, and they're not all dictated. So, the kinds of things you were doing were observing, detecting similarities and differences, looking for fit between a piece and the total puzzle and between pieces, and sometimes you were going at it trial and error. Yes. For example, you'd see, let's see, the blue piece goes with that blue piece because they're the sky. This piece has a straight edge, it must be part of the border, etc. There were comments of that kind from you, right? Okay. Now, a puzzle, more often than not, is an individual activity. Here, you are coming together to do it as a group activity. So that was different. A puzzle requires concentration over a period of time, enough to get absorbed into it, enough to absorb it, right? And you're right, you didn't have that. It is not a time-bound activity here, it was time-bound, all right? So don't kick yourselves if you haven't finished. And it is something that has an individual sense of achievement, and I'm glad to see that there is a collective sense of achievement as well. Okay. Now, how about science?
Yes.
Very often, just like jigsaw puzzle pieces, science happens by accident, right? And you find a fit between in a puzzle by accident many times, yes. And it is where it happens by accident that you have the greatest thrill. Yes. Right? Yes. In both cases, you have to prepare the ground for it to happen, and you have to let it happen.
there is a certain kind of mindset, a focus, and a preparing the ground. Just as you have to till the ground before you sow seeds, that has to happen. And that is what the purpose of these puzzles was, essentially. Okay. Now, what are the kinds of parameters to pay attention to? You tell me.
Not to lose a piece.
No, yes, of course, but
Not
when
to
you're
lose
looking at
patience.
pieces,
Try to
when
do the
you
border.
Classification.
traits of pieces,
Color,
okay,
color,
classification, color, what else?
Different patterns of
The borders. The borders.
So you have colors, textures, depth, how far something away is and how near something is. So edges and boundaries, boundaries and edges in terms of line, in terms of shape, in terms of color. You have objects designed, so like you said, the giraffe and the zebra and so on. You could have animals or buildings or people, right? And then you have uniformity, so for example, clouds in the sky, and merging towards the sky, gradual change of color, change of hue. Those are all clues that you're looking for. Now, what are the other parameters? You have the shape and size of the lock. These things have moved. So that's the lock. This is the second arrow is the key, and the third arrow is the shoulder. And the size and shape of each of these is a clue when you're doing a puzzle. Okay? Especially when you have flat surfaces, you have the flat white and so on, right? Okay. And then there are the very, very minute details of design and texture. These are details that you will see, you will notice only if you just stare at the pieces and if you have the picture as well. Okay? Okay. What do these categories, these parameters and traits of the pieces teach you? Or what is it, what's the parallel between this and science? It's practice and categorization for the purpose of fitting pieces together into a picture, whether in jigsaw puzzles or in science. Okay, there you go. Much like categorization in biology, where you fit all observations on organisms into a map of life forms to find explanations, right? So, the relevance. Scientific inquiry needs careful observation, paying attention to detail, categorizing, finding relevant traits, crucial, relevant traits, not just anything, seeing the fit between pieces, seeing the relation between the part and the whole. Okay. Each piece in a jigsaw puzzle is a counterpart of a data point, right? And the fit between the pieces is a counterpart of the integration of the different pieces of data in knowledge, in constructing generalizations, constructing theories, etc. Parameters along which puzzles can vary. So is the picture available? In your case, you made it unavailable to yourselves.
Yeah.
But sometimes a picture is not available. Is the shape available? Sometimes you don't have the picture, you don't even know what the shape is going to be. Do you know the number of pieces, sizes of sides? Do you know if the puzzle is free of missing pieces? What about the shape of the pieces? Is the shape consistent with your expectations? You would have talked about the shapes of pieces before. Is it consistent with that? Is the size of pieces easy to deal with, or are they too tiny?
Too tiny.
Okay, now every no in answer to each of those questions brings you closer to scientific inquiry. Attempting to do a jigsaw puzzle without a picture, not knowing how many pieces there are, not knowing if there are missing pieces, all these add to the uncertainty that you have. And one big difference, the puzzle, at least at the end, has one final picture, right? But scientific inquiry, there could be many pictures, many plausible pictures, and you're never sure if you've really arrived at the final picture. Okay? Okay. Is it possible to build even a rudimentary theory of... No? Shall we try? Okay? let's see if it's possible by limiting ourselves to a small corner of logically possible jigsaw puzzles. So first of all, let's assume that we're only talking about square or rectangular puzzles. The picture is available. We know that no piece is missing. The pieces fit our expectations derived from our experience of puzzles. Now, you talked about representation. Okay. So what do you think the units in a jigsaw puzzle would be if you're trying to construct a theory of jigsaws? Pieces, all right. What else? I mean, be more specific than pieces. Because
The locks and the keys.
all right, lock, key, shoulder, 3 units. What else? Edge, corner, puzzle, edge, corner, piece, side, lock, key, shoulder if you wish, that's not there. Some of the, this is not an exhaustive list. So you could start by constructing a list of units of representation and then use these units to make statements, state propositions that would be the principles that would hold on the puzzles. Now, first of all, you would categorize. Remember we said we are only talking about pieces that come under a certain class, where the ones that you're familiar with from experience. Using what we've said so far, the possible types of pieces and the units of representation, let's see, what are the kinds of things we can say? These would be our principles. Anyone state any, you already did on the first day.
Principle of solving a jigsaw puzzle.
No, principles, not of solving, of the structure of the puzzle. Okay? Yes.
There are an equal number of locks and keys.
Equal number of, there are as many locks as there are keys. Remember, we are talking about the kinds of pieces we are familiar with. So if suppose now, you're saying that you're imagining each piece to be a square or a slightly elongated square, which has 4 sides, right? That's how all of these pieces are in all 3 puzzles, right? Now that's a clue to build on. So go ahead, discuss this amongst yourselves for a minute.
You have to ask if that is true. Is it actually literally true that it's square?
Not a perfect square.
So why did you say it's a square?
It's square-ish.
It's a model.
Yes.
It's building a model. Yes. Like cow is a sphere.
That's true.
That.
If a cow is a sphere, then these pieces are squares. Yes. We're talking about principles of the structure of puzzles that would apply to all puzzles within the limits that we have stated. Okay, notice we're not talking about engineering, we're not talking about how to do it, but this is some kind of practice for you to think about how to build science, principles in science. Okay, go ahead. Yeah.
I don't know, but there's one unique key for every lock.
Uh-huh.
And one unique lock for every key.
So a unique match of lock and key, yes. You said unique pieces, right? I've come across pieces where part of the piece is not unique and therefore you mistake it to belong somewhere and then you have to go back and change it. Right?
Yeah.
Now do you get a sense of what principles are? All right. Can the 2 straight sides be just any of them? Can they be opposite sides? They have to be adjacent. All right? Okay. Now, with this in mind, see if you can add anything right here. Or we can go back to any of the slides that you want to, or you can later, or you can go and finish your puzzle.